Hello once again. Last time we stopped on the nth root of a complex number. So today we're going to see the nth root of a unit or the nth root of 1. So if you know that the nth root of a complex number is zk equal to the nth root of r into bracket cos angle over n plus 2k pi divided by n plus I sine angle over n plus 2k pi divided by n. So that's the formula for the nth root of a complex number. So when it is 1, for the nth root of 1, it means that our z must be equal to cos 0 degrees plus I sine 0 degrees. So you know that cos 0 is 1, sine 0 is 0, that is 1 plus 0i, which is 1. So we're going to find the nth root of 1. So which means that our angle will be 0. Our angle is what? 0. So if angle is 0, so from this formula, if angle is 0, 0 divided by n, it will be 0. So now the formula is going to change. The formula is going to become zk. Our formula changed to be zk equal to nth root of r into bracket. Because our angle is 0, that is 0 plus 2k pi to be cos 2k pi over n plus I sine 2k pi over n. So now, if our z is 1, if z equal to 1, what does it mean? The modulus, which is r, the magnitude of z, which is r, equal to the square root of 1 squared plus 0 squared. So now, our r will be equal to 1. So now, what is the nth root of 1? The nth root of 1 is what? 1. So which means that here, the nth root of 1 to be 1. So finally, the formula changed to be zk will be equal to cos 2k pi over n plus I sine 2k pi over n. So this is the formula for nth root of 1. This is the formula for nth root of 1 or unit. So where k is from 0, 1, 2, up to n minus 1. K will be equal from 0 up to n minus 1. So let us try to see examples. Examples. Number 1, find the cubic roots of unit. So we're going to find the cubic roots of unit. What is unit? Unit is equal to z equal to what? 1. When you say find the cubic roots of unit, it means that we're going to find the cubic roots of 1. So how are we going to do that? So if it is cubic roots, it means that our n is 3. So what will be our k? Our k will be equal to 0, 1, then 3 minus 1, it is 2. 3 minus 1 equal to 2. We're going to stop from 2 because our n is 3. 3 minus 1 will be what? 2. It will be 0, 1, 2. So we're going to find z0 from zk equal to cos 2k pi over n plus I sine 2k pi over n. So what is z0? For k equal to 0, it will be cos 2 into 0 pi over 3, because our n is 3, plus I sine 2 0 pi divided by 3. 2 times 0 is 0, 0 times n number is 0, 0 divided by number is 0. This is cos 0 degrees plus I sine 0 degrees. Cos 0 equal to 1, sine is 0 equal to 0, 0 times I, that's 0. So our z is 0 equal to 1. So we're going to find z1. For z1, it will be cos 2 k equal to 1. So now our k will be 1 pi over 3 plus I sine 2 into bracket 1 pi divided by 3. So now, what is z1? z1 is 2 pi over 3 cos 2 pi over 3 plus I sine 2 pi over 3. So what is cos 2 pi over 3? So cos 2 pi over 3, what is cos20? Cos20 is negative half. So z1 equal to negative half. Sin 120, it is negative, positive root 3 over 2 plus I root 3 over 2. So that is z1. So we're going to find z2. So z2 will be equal to cos 2 into 2 pi over 3 plus I sine 2 into 2 pi over 3. So z2 will be equal to 2 times 2, it is 4. That is cos 4 pi over 3 plus I sine 4 pi over 3. So what is 4 pi over 3? That is 240. So z2 will be equal to, what is cos 240? It is negative 1 over 2. What is sine 240? It is negative root 3 over 2. So we are going to just write the final answer very well, because cos 240, it is negative half, and sine 240 degrees, it is root 3 over 2. So then now, z2 equal to cos 4 pi over 3 plus I sine 4 pi over 3, where cos 4 pi over 3 equal to negative half, and sine 4 pi over 3 equal to negative root 3 over 2. So we have z0 equal to 1, z1 equal to negative half plus I root 3 over 2, z2 equal to negative half minus I root 3 over 2, which means that the cubic roots of 1 are, they are 1, negative 1 over 2 plus I root 3 over 2, negative half minus I root 3 over 2. So those are the cubic roots of 1. So number 2, we're going to find all the fifth roots. Find all the fifth roots of 1. We're going to find the fifth roots of 1. So it is the same formula. We're going to use the same formula, where zk equal to cos 2k pi. This is k. 2k pi over n plus I sine 2k pi over n. This is the formula for finding nth root of a complex number. Zk equal to cos 2k pi over n plus I sine 2k pi over n. So what is our n? Since we are looking for the fifth roots, our n is 5. So what will be k? Remember k is from 0, 1, 2, up to n minus 1. So n minus 1, 5 minus 1 is 4. So mean that our k will be 0, 1, 2, 3, up to 4. Because 5 minus 1 equals 4. So we're going to find Z0, Z1, Z2, Z3, up to Z4. So Z1, that's where k equal to 1. Z1 is cos 2 into bracket, we're going to start with Z0. Z0 equal to cos 2 into bracket 0 pi over 5 plus I sine 2 into bracket 0 pi over 5. So now what is the answer? Z0 equal to 2 times 0 is 0, that is cos 0, plus I sine 0. Cos 0 equal to 1 and sine 0 equal to 0. So our Z0 equal to 1. So from there, what is Z1? So Z1, it is where k equal to 1. So that is cos, we're just using this formula. We're using that formula. It is cos 2, where there is k, we're going to use 1 pi over 5 plus I sine 2 into bracket 1 pi over 5. So meaning that Z1 equal to cos 2 pi over 5 plus I sine 2 pi over 5. So this is our Z1. Then we are going to find Z2. Z2, that's where k equal to 2. So that is cos 2 into bracket 2 pi over 5 plus I sine 2 into bracket 2 pi over 5. So what is the answer here? Z2 is 2 times 2, that's 4, cos 4 pi over 5 plus I sine 4 pi over 5. So that is Z2. So we're going to find Z3. We're up to Z3 now. For k equal to 3, that is cos 2 into 3 pi over 5 plus I sine 2 into 3 pi over 5. So Z3 equal to cos 6 pi over 5 plus I sine 6 pi over 5. So that is for Z3. Our Z3 will be equal to cos 6 pi over 5 plus I sine 6 pi over 5. So now we're up to 4, where k equal to 4. Z4 will be equal to cos 2 into bracket 4 pi over 5 plus I sine 2 into bracket 4 pi over 5. So finally, Z4 equal to 2 times 4, that is 8. So that is cos 8 pi over 5 plus I sine 8 pi over 5. So that is our Z4. So we have 4 roots. We have 5 roots here. Z4, Z3, Z2, Z1, and Z0. So those are fifth roots of 1. So now from there, we're going to see exponential form of a complex number. We're going to see exponential form. We're going to see exponential form of complex numbers. We're going to see exponential form of complex numbers.